And welcome everybody to this video here. We're going to do problem 287, which is coming from this lesson here, 2.3.2. What is the equation of the line? You're going to find the equation of a line through 2 points. And that's exactly what we're going to do in this problem right here. Because even though you're given a table here in problem 287, you really just need two of these points, right? Two of these points to find the equation of that line. Because as we'll see in a second when we read through the question, it's going to tell us a line passes through of those points here. So anyways, let's go ahead and let's get started. Just read the lesson introduction to see what maybe our problem has to do with what you're going to learn today. It says, in the past few lessons, you have learned facts about M and B by graphing lines from equations. In today's lesson, you will reverse the process used in the last lesson so that you can find the equation of a line when you know its graph. All right, so it looks like later in today's lesson, you're going to have graphs and maybe only some of the information about a graph, and you're going to use that to get the equation. So in order to get you ready for that, we're going to start talking about tables right now in problem 287 to maybe show you that you know a lot about this, and you're just going to have to do this for a graph later. Okay, so in problem 287, it says, in this problem, you will find the equation of the line that goes through the points in the table below. Use the questions below to help you organize your work. And here we have the table. Okay, so make sure you're reading questions carefully here, because one of the big things that it gives you is that this is the equation of a line you're finding. The line goes through these points here. So we don't have to worry about this table being some sort of nonlinear function or nonlinear representation. We know it's going to be a line. And when we know it's a line, we know that our equation is going to be in a particular format. And that equation is going to be in the format y equals mx plus b, because that is the slope-intercept form for the equation of a line. It's the best way we have for right now for getting the equation of a line here. Hey, there's another thing before we get started on this problem that I wrote here on the right side that I just kind of wanted to have in front of you, because I consider it to be one of the most important formulas in all of Algebra 1. In fact, for my own students, I call this the tattoo formula. In that, right? I know you're inspired here, inspired by us, these Algebra 1 videos we're making right now, making for you guys. You're inspired by your Algebra 1 teachers. Yeah, ask them. They probably have this as a tattoo on their body. I'll tell you, get a tattoo. You want to be inspired? You want to get some math-related tattoos? I'd say get this one right here. Oh, yes. And put this on your body, right? Tattoo it. And why do you say I say tattoo this particular formula? Oh, because that formula is just so important, right? It comes up a lot here. And of course, we're looking at here the formula for slope. M is, in the equation here, represents our slope. And to get our slope, we actually have a particular formula that we can use these numbers to help us out with here. So this is the formula for slope. And in order to determine m, we have this kind of fraction set up for us here. And in the numerator, we have y2 minus y1. And the denominator, we have x2 minus x1. And that's exactly what we're going to do here in the first problem, because it's asking us here, what is the slope of the line? What is the slope of the line? Okay, very good. So in order to get the slope of the line, I'm going to start with maybe recopying my slope formula down here. And I got to find my slope m, and that's going to be equal to y2 minus y1 over x2 minus x1. And you might be thinking, right, if you're still having a little trouble with this, about what exactly the 2's mean and what the 1's mean right there. And what the 2's and 1's mean is that they stand for the points you're taking, So for instance, maybe we can just use this right here as point 1, right? This here can be x1, and this here can be y1. So this is point number 1 right here. We have a point at 2997 that the line goes through. We have another point right here that the line goes through. So we can call this the x-coordinate number 2 and the y-coordinate number 2. So all we need to do is find the difference in y2 minus y1 over x2 minus x1, because this represents right here, right? It represents our change in y, right? This is just a different way of writing the change in y. A difference is a change. So subtraction here, we take a y-coordinate, subtract the other y-coordinate, we get a change in y over a change in x. And that's what we're going to do here. Okay, so let's do it. y2 minus y1. So y2 is 64 and y1 is 97. And we're going to set that over 18, which is x2, minus 29, which is x1. And with that, we just need to simplify our fraction here. Again, start with grouping here. We're grouping this in the numerator, so we can simplify this. These are like terms right here. 64 minus 97, we're gonna get a negative answer right there. And because I like to save my brain power for things, I'm going to do, not even going to do it in my head, I'm going to just use my calculator for it. And I got negative 33 in the numerator. And in my denominator, it's a little bit easier for me to do in my head. I get 18 minus 29. Well, that'll be a difference of negative 11 as my answer, right? Bigger number here. And this here is our slope. Is this the best way we can write our slope as an answer, though? Well, we have negative 33 in the numerator and 11 in the denominator. So when you have both the numerator and denominator are negative, you can just make them both positive, and that would be a legal move because, right, it's technically dividing -1 by -1 makes them both positive. But this could actually be simplified further, right? 33 parts over 11 parts, well, that is in a 3-to-1 ratio, or you would get 3, right? The fraction bar obviously just means divide, so take 33, divide it 11 ways, and you get 3 as your answer for your slope. So part A was just a way of practicing this formula, the formula for slope here to get our M, which is great because that's going to help us get our part of our equation right here. We got our M. Part B says, does it matter which points you use to find the slope of your line? Find the slope with 2 other points to verify your answer. Well, this, I know our answer here, it's going to be no. It does not matter what points you choose because we know that the line goes through all of these points here. So you just need 2 points that go through the line, and then you can use any of them. And remember, lines, because they're linear, they have a constant rate of change. So that the slope between any 2 points in the line should be the same, or it is the same because it's a constant rate of change. The slope is a constant rate of change. So let's choose some different points right here, and I might do that in blue. So now let's choose these ones. I'll make this one be my x1 and y1, right? This is my first point here. And then this will be my second point right here. So I'll do x2 and y2 here. So let's see if we get the same thing. M equals y2 minus y1 is 52 minus negative 14. You got to make sure you're going from one point to another. So if I do y2 minus y1 this way, then I'm going back to my original points, right? Or my second point here, and putting that down here. So and one way to double check you're using your slope formula correctly is that the coordinates, so your y coordinate and your x coordinate of the same point should be directly above one another. So this is y2, and that's directly above x2. And then you're going to subtract out x1, which is -8. And notice here that I have my y1 over my x1 here. Just one way to make sure you set up the fraction correctly. A lot of times the common error people make is that they do y2 minus y1 and then they do x1 minus x2 because they're already looking at the first point when they're doing this part here. Anyways, try to avoid that. Common error alert. 66 here. So subtracting a negative means adding together, and 52 plus 14 is 16. And then here we have the same issue. We have a double negative right here. So double negative, make it positive. 14 plus 8 is going to give us to 22. And here we see the same thing. 22 goes into 66 3 times. So our M here is 3, and we are good to go. Part C here, how can you use a point to find the equation? Find the equation of the line. Okay, interesting here. So it's already just having us jump to the equation. Oh, interesting. Okay, so we got to think, what parts of the equation do we have? What do we need to find? So remember, a linear function is written in the form y equals mx plus b. Mx plus b. But when we get the equation of the line here, we don't see y equals mx plus b, right? We don't see y equals mx plus b. When we're eventually going to get the equation of this line, what letters do we see in our final answer? And what letters get replaced with numbers? Well, we already have a letter that we know a number. So for instance, we know that m is 3. M is 3. So m is going to be replaced with 3 in the equation we eventually get there. And remember that x and y are called your independent and dependent variables. So those are variables that apply to this specific problem. Notice here, we have a whole bunch of x's, a whole bunch of y's. So are any of our x values and any of our y values going to appear in this equation when we find the equation, when we've done it? No, it won't. That's the difference between parameters, right? But the parameter variables of the equation and the independent and dependent variables of a situation, so of an equation. So m is a parameter, and then your other parameter is b, and we don't have b yet. But what we can do, what we've been doing the past few lessons, and what you're practicing right now, rehearsing right now, and what we got to do is we need to solve for b. Okay, so the way that we solve for b, we're going to take this m, right? We're going to take this m that we got in the last couple steps, which is 3, and then you might be thinking, how am I going to get b if I only know m? Well, the question here, what can I drop in for x? What can I drop in for y? Is there values that I can drop in for x and y? Well, in fact, there are, right? The fact there are a whole bunch of x and y values. And what makes these points on the graph, right, points on the line, is that these coordinates will satisfy the equation we're trying to write. So just like with slope, where you can use any 2 points that are on that line. So we use this point here and that point there to calculate a slope of 3. And then later we choose different points, right? This point and that point here to calculate a slope of 3. Just like that, we can use any of these x, y values, because these are solutions to the equation and therefore are on the line. We can use any of these points, a single point here, to plug in for x and plug into y to the equation, and that's just going to leave us b here, right? We got to figure out what b is to make the rest of our equation and make it so x and y actually are solutions. Okay, it's a lot easier if we just see it and kind of do it together, and hopefully you've done it in the previous lessons here. So I'll color code this here. I'll go with maybe some orange here for the y value, and I'm going to take, these are kind of some scary negative numbers, so I'll kind of avoid those. So I'm going to go back to this point right here, which are kind of slightly lower all positive values. So we have 64 here, and that can be my y value, so I'm going to put that right here. So 64 is a y coordinate. It has a y coordinate on the graph, and its corresponding x coordinate is 18. And I'm going to take its corresponding x coordinate of 18, and I'm going to plug that in for x. Since m is being multiplied to x, I got to do parentheses, and I'll put that here. Okay, so m gets multiplied to x, and then b gets added to it. Do we know what b is yet? We don't know what b is yet, but we know when we add b to the slope times the x, we're going to get the corresponding y value. So we're going to get 64 here, okay? Is this an equation that you can solve? Yes, I hope you can solve this at this point. If not, pay attention and continue practicing these ones, and I know you can get better here. There's only one unknown. When we have one unknown variable now, we can usually solve that equation, knowing the tools that you already have here as math students. So I'm going to simplify this down. Left side, nothing to simplify. Right side, we got 3 times 18, and I can use the calculator. I can also reason through it. Well, 18, that's 2 less than 20. So if I do this in my head, 3 times 20, that's 60. And then I'd have to take away 3 times 2, right, from that. So I'd have to take away 6 from that. So 3 times 18 is 54. 54. And get those mental math tricks to save yourself some time and some sanity on problems like this here. So now we have this here. If b gets added to 54, and that's what equals 64, obviously we can guess and check. We know b is going to have to be 10 there, but you can also do your solving step here, that if you're adding a 54 to a b, then what gets rid of that adding of 54 is subtracting that 54 from both sides. If it takes adding that 54 to b to get to 64, then if we subtract 54 away here and subtract 54 from this side, we'll solve for b. And b is going to be 10 here. Okay, b is 10. And see here, it says, how can you find a point to find the equation? Find the equation of the line. I didn't really explain that written out here, but we got the equation of the line here because now we have b. We have m up top here. So that means the equation of my line is going to be y equals 3 times by x plus 10. Notice here, which variables got replaced in the equation when we wrote our final equation, and what variables remain, right? Remain here. So it's asking you to find the equation. What letters should you still see in that equation of the line? We still see x, we still see y. Remember, y, those are the independent and dependent variable. They're going to be changing throughout the situation, right? Changing throughout the situation. But the y-intercept, the starting number, is always the same. We have one starting number there, and that's 10, right? 0, 10 is the y-intercept. And then we have one slope, one rate of change, which is 3. So those parameters, those sort of special sauce that make the line special, where it starts, how fast it goes, those are the things, that's the information that we're going to want to see in the equation, because that's what makes this line special here, not the x and y part. All right, part D, once you have the slope, does it matter which point you use to find your equation? Why or why not? So it's talking about, right, once we have the slope of 3, and did it matter what point we used? So I used 18. I dropped in 1864 to get my equation, meaning to solve for B. And yeah, it didn't matter which one you use. And here's my complete answer. It doesn't matter what point you use to get your equation, because all points in the table would be solutions to the equation. Once you add them, they're solutions. So any of these points can be used to solve for B. They should return the same B to you, as long as you're using that 3 for slope and you're using a point on the line. How can you verify your equation is correct? There are a few things you can do, but probably the easiest thing is what we can do is we can plug in or substitute So plug in another xy point from the table into y equals 3x plus 10 and confirm that it is a solution. So again, any point on the line is a solution to your equation, is a solution. That's what means that it makes it on the line, right? The line's going to travel through it. Sort of the graph is kind of your map of the equation on the xy plane, a map here. So if I take a different point, one that I didn't use here, right? I got to cross off 1864. I'm not going to use that point because that's what I used to get my equation to solve for B, to get y equals 3x plus 10. So I'm going to use a different point. So perhaps I use 1452 because that's also two positive numbers, also kind of low like these are here, not as big as this. So maybe I plug that into the equation to see if I get the correct answer. So now I've plugged in 14 for x and 1552 for y into this equation here. Y equals 3x plus 10, and I'm going to confirm here that it is indeed a solution to the equation. 3 times 14, well, 3 times 10 is 30. 4 times 3 is 12, so that's going to bring us to 42, and then we have that starting number getting added to that side, and that's going to bring us to our y coordinate when x is 14, which is 52. So this checks out here because our right side is 52, and that, of course, is equal to itself here reflexively. So we check it out. So this is on the graph. And we knew it was on the graph, right? We knew it was on the graph, but we know it's now in the solution of the equation too. So we know that our equation is correct. And that's it for problem 287. Okay, so keep these ideas in mind here as you do the rest of this assignment here. So you're going to have these equations here, and it looks like you have 2 points. Looks like you have 2 points on a whole bunch of different line segments. We're just going to get the equations of a line on these ones though, using those 2 points. So have that tattoo ready to go, and then keep this in mind. You can use those 2 points to get your starting point. Email if you have any questions. Thanks for watching. Take care. Bye.